Assalamualaikum. This is part 2 of the list video. In this video, we will look at array implementation and linked list implementation of lists. Do you recall that a list is a sequence of 0 or more objects? And the basic operations include searching, inserting, and deleting. One way to implement a list is by using arrays. All of us know that arrays store multiple data of identical type, where the length is specified during compilation. The list will be stored in the array in a contiguous manner, and the rest of the array is considered empty. The first element of the list will occupy the first slot in the array. Supposedly, this is our list. Searching for an element in an array is pretty straightforward. We simply start from index 0. Just traverse down the list until we find what we're looking for. If we want to insert, and we intend to insert one element X at index 2, this insertion is possible because the size of list is still less than the size of array. However, if the size of the list is already the same with the size of the array, it is not possible to add anything else. In order to insert one element into the list, all elements from that position onwards have to be shifted to the right by 1. Shifting must be done starting from the bottom. So X is inserted in the designated space. Next, let's examine how deleting is done. Deleting is only allowed if the number of elements is more than 0. Suppose the second element is to be deleted. All elements thereafter must be shifted to fill up the gap created by the deleted element. The list is reduced by 1. As you can see in the examples above, for insertion and deletion, the shifting of array elements in one or the other direction will occur quite significantly. And the example above uses a small array size. Imagine a real-life situation with hundreds of array elements. Thus, the shifting of elements can be very costly. Next, let us try to understand linked list implementation of lists. A linked list is a series of connected nodes. Where each node contains at least one piece of the data and the pointer to the next node in the list. In other words, the connection between the nodes are established by using pointers. The beginning of the list is marked by a head which points to the first node, while the last node points to null. As mentioned in the array implementation, all elements are stored contiguously. Linked lists, on the other hand, store elements in non-contiguous locations. Even though frequently, a linked list diagram shows a trail of elements. There are several variations of pointer-based list. First is the singly linked list, where the list starts with the head pointer and ends with the null. Second is the doubly linked list, where every node have two sets of pointers to the previous and to the next node. And there are two nulls. So question is, what is the advantage of a doubly linked list? The third variation is the circular linked list, where there is no null, but the last node points back to the first node. Since there is no null, how do we know we are at the end of the list? Let us examine the operations of a linked list. Searching for a particular element in a linked list requires a pointer, say next, and keeping track of the index value. The index value has to be manually updated. We will now see how we insert new nodes in a linked list. Suppose we need to insert a new node as the third element. We are inserting the node X. X is marked by the pointer new. First, we will traverse the list from the head pointer until we find a node that points to the position to be inserted. In this case here, where B is pointing to C, we assign the pointers of X with what is pointed by B. We adjust the pointers of B to point to X. So the list elements has increased by 1. Next, deleting with linked lists. Say the fourth element in this linked list is to be deleted. We will need 2 additional pointers to assist us. We could call them next and previous. Every time we advance the next pointer, we check if that element points to the element to be deleted. If it is not yet matched, the previous pointer will now be advanced. As soon as the next pointer points to the elements to be deleted, we assign the pointer of the element pointed to by previous to point to the element pointed to by the element to be deleted. Once the node to be deleted is removed, total number of elements is reduced by 1. Comparing between array-based implementation and pointer-based implementation, memory space allocated for arrays is fixed and static throughout the program. For linked list, the memory space is dynamically allocated. However, a little extra space is needed for the pointers for each cell. Since the size of arrays are static, we must make good estimate of how much space is needed. Linked lists, on the other hand, can easily grow and shrink in size. Insertions and deletions are more difficult to make in arrays because of shifting to the left or to the right. Whereas in linked lists, only a few adjustments of the pointers have to be made. Most programmers will think that implementation by using arrays are more straightforward to code and managed. If you have more questions regarding lists, do forward your queries to your instructors. That's the end of the video, and have a nice day.